Okay, let's take a look at the final problem on tutorial sheet 7. This is example 3. So a stock is currently priced at £100. During each 3-month period, for the next 6 months, it will increase by 10 or decrease by 10. So the multipliers 1.1 and 0.9. Risk-free rate is 8%, compounding quarterly for the first 3 months, and 6% per annum with continuous compounding for the remaining 3 months. Okay, so we got one rate at 8 and another rate at 6. Okay, what is the initial value of a 6-month look back put option with this floating strike price? Okay, so part 1 of this question should be pictorial representation, showing all the movements in the price. So we have 3 months and then a 3 months. This is 6-month position. Yep, 6-month position. Okay, so we have an up or a down in the share price, which is 110 or 90. Numbers are quite simple, just 10%. Then we have an up situation, 21, up, down, take 10% off that, 11.99. Then we have a down, up, which is same as up, down, and finally a down, down position, which is 81. So that's the stock. How about the option? Well, we don't know what the option is at the beginning. It's going to have values depending on whether the share rises and falls. And then again, it's going to rise. So up, or rise and fall, up, down. Then we're going to have a down and an up, and finally a down and a down. Okay, I'm just going to for later just label some of these. So A, B, C, D, E, F. Okay, it's a put option with a look back, which means that the strike we can use is the maximum of the share prices looking backwards. Okay, it's a bit more fun, this calculation. So if we start at the top, so it's a put option. So we have the share price is 121. We take off K. K is the maximum looking backwards. So we got this one, or this one. So the biggest is 121. So we have the share price. So we have the strike price take away the biggest share price, which is 0. Okay, now suppose we're at E. So we got there from an up and a down. So now we need the different color. Let's try this one. The biggest share price, if we're here and we're looking backwards, so it could be 99, 110 or 100. So the biggest is 110. So K is 110 minus the share price, which gives a value of 11. What about the down up price? Yeah, so we need to be careful here. It's not going to be the same as 11, as we shall see, because we're not following the blue, we're following the red. So we got to the 99 by taking the down and up path, and the largest share price now is 100. If you look at the red, the largest is 100. So in this case, the value of the option is 1. Okay, and the final one, okay, I'll find a nice color, purple, this will do. So we're here, we come this way, the biggest is 100, so the price is K, which is 100, take away the share price, 81, giving the value of the option as 19. There you go, that was quite fun, made me think a little bit, but it's quite good fun. System timescales, so we're using 3-month scales, so delta T is 3 months. Okay, so that's the complete picture of all the movements. So what's the question? We're finding the initial value using the risk neutral probability. So let's do that. So we need the risk neutral probability at the positions. Let's take a look. So we need to find them at B and C. Okay, so let's say Q2 is the risk neutral probability at C. Because the interest rates are constant over 6 months and the multipliers for U and D, they're constant. So actually we're going to get the same values at C and B because the equation we can see is just this. And it's the same whether we're at either of those nodes. Okay, so now we need the rates. So we have E 6% times 3/12, take away 0.9 divided by this, which gives a risk-free probability of 0.5756. Okay, so I've now got Q, so I can now work out the values of the option at B and C. So the value of the options at B and C are, so let's do that next. So this is straight off the formula sheet. It's the weighted average, and then we discount it to the 3-month time period, which gives the following. We have, let me see, 0.5756. Take this off the picture. Take that off the tree. which gives, by my calculation, £4.5989. Okay, we're not finished yet, far from. We've just calculated the value of the option at node B, and we can easily calculate it at node C using a similar idea. I've run out of space. One page should be enough, I think. Soon find out. Okay, so this is VU and VD is the weighted average discounted from 6 months to 3 months. That's off the formula sheet. This is from the market information in question. This is from the tree. The values are 1 and 19. Using the risk neutral profit. Sorry, yeah, probability, risk neutral probability. Drop all those into a calculator. We get around £8.51. Okay, so we've got the, let's go to the table now. We've got the values of this one and this one. We use the weighted average from here and here to calculate this one, and from here to calculate this one. Now we can use these two to calculate this one. Okay, Q is going to be the same, so we can take the weighted average of these two, the expectation I mean, and then discount it to get this one. Okay, it's quite messy, these calculations, really make you think. Right, so now we need the risk neutral probability at point A. So I'm just going to put this into a sentence. To compute the initial price of the option, we need to find the risk neutral probability at node A. So let's do that. Q1 is the risk neutral at A. Straight off the formula sheet, that's the equation. Okay, so now we're using slightly different rates. So we have 8% compounding quarterly. I'm just going to give a different Q to really testing whether we understand this. We have 60% chance of a rise when we're at node A. Hence, the initial price of the option is, let's do it straight off the formula sheet. We calculate the weighted average of the values of the options using risk neutral probability and discount that by 3 months, which gives this really is a big calculation. Okay, we've calculated VU and VD. Oops. And we drop all those in, and then we're done. Okay, so that's a calculator job. I've already checked this in the calculator, but my calculation is £6 and about 4p, which completes the question. Okay, so I'm sorry, that's quite a long video, lots of calculations. I would go through it and just pause where necessary and just make sure you can follow all the steps. All the details is in there. I hope you find that useful.